My name is Scott Flanagan, student number A00034847. Power factor and circuit analysis. This presentation covers the fundamentals of power factor, the power triangle, and a practical calculation of the specific AC circuit. 1. Definition of power factor. Power factor is the ratio of the real power flowing to the load to the apparent power in the circuit. It is a dimensionless number between 0 and 1. Real power, the actual power dissipated as heat or used to do work, measured in watts. Apparent power, the product of the RMS voltage and current measured in voltamperes. Formula, where phi is the phase angle between voltage and current. The power triangle is a geometric representation of the relationship between real power, reactive power, and apparent power. Real power, the horizontal adjacent side watts. Reactive power, the vertical opposite inductors and capacitors. And apparent power, the hypotenuse.
My name is Erik, and my student number is A00024193. Power factor correction, or PFC, is the process of adjusting the power factor so that it is closer to 1 or unity. It is usually done by adding capacitors to a circuit that contains inductive loads, and a low power factor means that a higher current must be drawn to produce the same amount of useful work, so a waste. And this causes greater energy loss in cables and can sometimes lead to penalties from electricity providers, so paying for more and getting less. Capacitors improve this situation by providing leading reactive power that cancels out the lagging reactive power. In a practical circuit example, the voltage is 190 volts and the frequency is assumed to be 60 hertz. The resistive load is 3.2 ohms and the inductive load is 13.74 millihenries, or 0.01374 henries. The inductive reactance is calculated using the formula XL equals 2 pi FL, which gives approximately 5.18 ohms. The total impedance is then calculated using Z equals square root of R squared plus XL squared, given approximately 6.09 ohms. The power factor is found using PF equals R over Z, which results in approximately 0.525. The current in the circuit is calculated using I equals V over Z, given approximately 31.2 amps. Then the real power is calculated using P equals I squared multiplied by R, which equals approximately 3,115 watts, or 3.12 kilowatts. The apparent power is calculated using S equals VI, which equals approximately 5928 VA, or 5.93 kVA. The phase angle of the circuit is approximately 58.3 degrees.
Samuel iheguente A00034270. UN Framework for Energy. The UN aims for universal access to affordable, reliable, and sustainable energy. Efficiency is considered the first fuel because the cheapest and cleanest watt is the one you never have to generate. The triple pillar. This is the UN strategy which focuses on electrifying end uses like EVs, raising building standards and performing technical upgrades on industrial machinery. Is wasted energy, such as reactive power. Many industrial machines, such as motors, pumps, pull reactive power from the grid to create magnetic fields. This power doesn't do real work, but takes up space in the wire. Is the power factor. This is a measure of efficiency. A low power factor, an example which is 0.70, means 30% of the energy being drawn is effectively being wasted as heat or unnecessary current. And a solution for this is power factor correction. Local neutralization. This is when the power factor uses capacitor banks to provide the necessary magnetic energy locally at the machine, rather than drawing it from a distant power plant.